Welcome to chapter 18. And in this chapter, we are going to discuss the various strategies for query processing. By the term strategies, we refer to the various approaches and techniques to better process the queries. It includes the different approaches used by DBMS to faster execute and quickly retrieve the results out of a given query. The goal is to efficiently process queries and minimize the time and resources required to fetch the data out of a desired query. Different strategies can be applied at various stages of query processing. The steps the steps required to carry out a query processing is given in figure 18.1. Let me take the cursor, laser pointer. Yeah. Figure 18.1 elaborates or illustrates the typical steps when processing a high level query. The high level query is given by the user, and then the DBMS tries to get the results out of it. Behind the scenes, it is going to perform phase one, phase two, phase three, and phase four steps to produce the query. In this chapter, we are going to see what we do, what is being done at each stage, at each phase. For example, after the query is written in a high level language, it is scanned, parsed, and validated, which produces an immediate form of a query, which is fed into a query optimizer. Query optimizer creates many execution plans out of which the best is selected. So the output of the query optimizer is an execution plan. This execution plan is then fed into the query code generator. Then we get code to execute the query, and then which is fed as an input to the runtime database processor. Now, at this stage, the execution can be done directly, which is called as interpreted mode, or it can be written, stored, and executed later whenever it is required, and this is called as a compilation mode. Hence, with this, we understood that a query can be executed in one of the two ways by using interpreted mode, wherein we execute the query right away, or the compilation mode or the compile mode, where we store and keep the query to be executed later whenever it is needed. This is called as compile mode. Throughout the chapter, we are going to discuss all these phases in considerable detail so that you get understand what is query processing is all about. Okay, now query processing. If you define the query processing, it means that it is the process by which a DBMS translate a user query into an efficient series of operations that retrieve the required data from the database. Now, trying to understand what is this figure all about. Scanner identifies the tokens given inside the query. Okay, so what is the job of the scanner? The scanner, okay, let me take a pen. Okay, pen, okay. So the query tokens are identified. Scanner does the job of identify the tokens. Parser checks the syntax. Validation checks that all the attributes given in the query and the table name exist in the DBMS or exist in the database. Okay. Query tree is then created. Okay. The query tree is created and a query graph is created. And then what happens? An execution plan is created. Okay. Execution plan, or also referred as query plan, is created. Now it is the job of query optimizer to plan a good execution strategy, Okay, now let's see example of this. Okay, now if you see, okay, we'll come back to this again back. Okay, now scanner is doing the job of identifying the query tokens. Okay, identifying the query tokens given in the query. For example, if the query is select first name, last name from employees where department is equal to IT, then the tokens identified in this SQL query is nothing but select. Okay, this is one token. Okay, this is another token. This is another token from employees where department equal to IT. Okay, all these are the tokens that have been identified in this given query. Okay, now a parser will check the syntax. For example, is there any comma missing here? Is there any semicolon missing, or the spellings are correct? Okay, or the parser checks the syntax job. Validation checks that all the attributes like first name, okay, last name, and department and employee table exist in the database. Okay, and then a query tree is created. Okay, now let's see how does a query tree and a query graph looks like. Okay, for example, here we have another example of a query which is trying to select the two columns, name and salary. Okay, where the department number is equal to the department number given in the query. Okay, and the department name is marketing. Okay, coming from the department table, and employee, employee name is coming from the employee table. Okay, and salary is coming from the employee table, but we want to fetch the name and salaries where the department number is equal to the department number of employee, and the department name is marketing. So this is the query tree created for the query. Here we have another example of a query where a query graph is being carried out, which involves a technology table, company table, and a person table. And we want to find and we are making a graph by connecting all these tables, and then we want to select the person name Jennifer working for a company name Neoj. Okay, and then likes the technology, for example graph, and the name of the person. Again, we have another person here, Michael. This is just a query graph. This is just a representation of a query graph wherein we connect the tables by using nodes and edges. Okay, so a query graph is created. So if you see the process, a query is written, parsers checks the syntax, validation makes sure that that the attributes and the names given in the query are available, and then a query tree or a graph is created. You make translate a given query in a form of a tree or a graph. Okay, so this is the job that is being done up till here. Here execution plan. Okay, now yeah, now this is sent to the query optimizer. Okay, now let's see the translating SQL queries into relational algebra and other operators. Okay, now we have been seeing here projection, selection, and uh, things like writing the query and executing. So we have here next query selection used in RDBMS. Okay, so SQL is nothing but a query language used in most RDBMS. When we write a query, it is decomposed into different or smaller query blocks, which forms the basic units that can be translated into algebraic operations. Okay, which contains select, from, where expressions. It may have group, by, and having clauses. Okay, for example, translating an SQL query into something like this, into something like the relational algebra. So basically, this SQL query we are writing is translated into the relational algebra, something looking like this. We will come to this point and then we will again understand what's happening here. So yeah, the query is given in SQL. Okay, it is divided into query blocks. each block might have certain parts of a query represented by using select or project or from or where, and then it might also have some clause like having or group by. Now, for example, let's take selecting the last name and the first name from employees table, where the salary is greater than the maximum salary from employee, where department is 5. Now, what do we mean by this? Here, actually, we have two queries. We want to select a person who is having the maximum salary in department 5. Okay, so this is, the smaller query. It will give us, for example, 5,000. Okay, as the maximum salary. Now we want to select all the employees' first name and the last name from the same table where the salary is greater than 5,000. So are you getting the point here? We are doing two tasks here. One is we want to know who is earning the highest salaries, or what is the highest salary in department number 5. Okay. And we want to know all the employee names who are getting this high salary or more than this salary. Okay, maybe they can come now in this case, they can come from any other department as well, but we want to compare it with the department number 5 maximum salary. Okay, select the maximum salary from employees where department number is 5. So what it will do, it will select the department number 5 entries, pick up one row which is having the highest salary, max of the salary, and then replace it here. So what is the result of this inner query? A number, right? A number, for example, 5,000. Now, this becomes another filter for the outer query, wherein we say select last name, first name from employees where the salary is greater than 5,000. Okay, here the inner block is the subquery, the outer block is the outer query. Okay, now let us translate this into, so what happened here? The first step is you wrote the query in the SQL language. Okay, then you divide it into the blocks. Okay, for example, this is one block, this is another block. Okay, and then each block is giving you some output, and then you are combining the output. Okay, after that, what is done? It is translated into relational algebra. And here we use the select and then the project. Okay, and for the inner query. Okay, so this is the inner block translated into relational algebra. We say select the maximum of salary where the department is equal to 5. Okay, from the employee. The outer block. Okay, so it will give us a number. For example, it will go to the department 5 in the employee table and select the maximum salary. We are assuming that it is 5,000. We are assuming, let me write down here. We are assuming it as 5,000. Okay, and then we are trying to project. Okay, this is called as project. This is called as select. Where do we use project? We use project where we have to select the columns. We use selection in relational algebra where we have filters, okay, where department is equal to something like that. Okay, so this is project, this is select. So we are selecting a salary greater than 5,000. Okay, 5,000 is this only. Okay, 5,000, and we want to get two columns for that. Last name and the first name. Okay, so this is the second phase. Okay, now the other one is query optimizer. Query optimizer will choose the execution plan for each query block. Okay, now let's see what is that. Okay, now we are making the selection for 50,000. That's okay, no problem. Okay, so we are saying select first name, last name from employees where department is equal to, okay, instead of saying IT, we'll say it like 5. Okay. So here we have an example of the query tree. This is plan 1 and this is plan 2. Okay, so what are we doing here? For example, we are first selecting the first names and the last names, and then we are checking the department is IT or 5 department, no problem, and then the salary is greater than 50,000. Okay, so it is something like, for example, if I want to know the student, names, first name and the last name, whose GPA is greater than 4. So now there are two approaches. The first approach says that get me the get me the names, okay, get me the names of all the students, out of which I will pick up the students who have GPA greater than 4. So it's like I am selecting all the students first, and then from it, not all will get the GPA greater than 4. So I will pick up few of them. So here, the execution plan is, for example, if I have 100 students, I will pick up all 100 students, out of which only, for example, 8 have, GPA greater than 4, 8 students have GPA greater than 4, then I will, select 8 out of 100. So are you understanding? Selecting first all the students and then picking out up only those students who have GPA greater than 4 is making 100 scans, and then this is the additional cost. So what we can do is we can have the GPA selected first. Okay, so I will have only 8 scans for the student, like, um, here I will just have the GPA selection based on the grade greater than 4, right? Now, then based on that, so I will have only 8 such cases, and then for 8 students I will take the first names and the last names. Simple, right? So the second approach is much better, right? So here, this is what we are doing. We are first of all selecting all the first names and the last names. Then we are going to the department and checking the salary greater than 50, and the department number is 5, or the department is IT. Okay, and then we are scanning the employees. Okay, so the plan one says that scan the employee table first, apply the selection. Okay, select first IT, then select greater than 50,000, and then select the first name and the last name. And for example, here assume that 80 units is the cost for doing this work. The second is scan the employee table. Okay, select the first name and the last name, then apply the filter criteria IT and salary greater than this. Okay, so this is of course more expensive than the plan 1. Plan 2 is more expensive, right? Because here again, it's like 100 scans required. For example, we said that if I want to select all the students, then picking up the students who are having GPA greater than 4 is going to be more expensive. Rather than that, I can select the GPA greater than 4 first, and then get those records and select the first name and the last name out of it. So the cost comparison, this is called as the cost comparison, wherein we look into the initial plan, the first plan, and the second plan, and select the best one. Okay, and then we execute the result. Okay, so this is the job of the optimizer. Okay, so until here we are, we are creating a graph. Okay, and then this is submitted to the execution plan, and then the optimizer selects the best execution plan. Okay, so this is about the scanning, parsing, and validating. Okay, creating the immediate query form, and then query optimizer will select the best execution plan. Okay. The additional operators that are used in join, that is, take two examples of semi-join and anti-join. Using join, we can join two tables, right? Now, a semi-join is generally used when we are trying to unnest the query which have exist in or any subqueries inside it. These are the phrases that we are going to join the subqueries with by using any or exist or in. For example, if we have a table 1 and table 2, and then we want to join them by using a semi-join S, then a column in table 1 value should be equal to a column in table 2. For example, here we have table left and here we have a right column, a right table. A row of T1, table 1, a row of T1 is written as soon as it is found in the table 2. Now, when we find this, at least one entry of X also available in Y, then we return this without searching for further matches. This is called as semi-join. Now, let's take an example. Let's take an example. For example, we have table 1 called as doctors and table 2 called as appointments. Now, the condition is if doctors d dot doctor id and is equal to appointments dot doctor id, it means the doctor is having, we're trying to search a doctor who are having some appointments. In this case, because it is semi-join, it will be at least a 1. Okay, indicating that we are looking for a doctor who have at least one appointment. This is at least is important in this case. Okay, at least one. Let me underline it. At least one. Okay. A row from the doctor table is written as soon as a match is found in the appointments table. Now, when at least one row is found, it is returned without searching for further matches. This ensures that each doctor in the result set is associated with at least one schedule appointment. It means we have a doctor who is having at least one schedule appointment. We have another example here that is used for students and enrollments. Okay. Now here we have students in the left table, enrollments in the right table. Okay. Now the condition is when the S dot student ID matches with the SE dot student ID, it means that a student is having an enrollment in the course. Okay. Indicating that we are looking for students who have how many? At least one. Again, when we are talking about semi-join, we just see if there exists at least one. Okay. So now a row from the students table is written as soon as a match is found in the enrolls tables without searching it for further. This ensures that student in the result set is associated with how many? At least one course enrollment. Okay. So this is about the semi-join. Okay. Now, the opposite of it is anti-join. In the anti-join, we have a left table, we have a right table. Okay. T1 is your left table, T2 is your right table. In this case, a row of T1 is written only if T1 dot X does not match. T1 dot X does not match with any of the T2 value. Okay. Any of the T1 dot X does not match with any of the T2 value. Okay. So in this case, what happens? We have to check the first value from the, for example, the first row with the first row of the second table. Okay, the second table. Let me draw. So first table is first row is checked with the first row of the second table. Then if it is not found, then we search again, then we search again, then we search again. And if we do not find a match between the first row and all, after comparing all the rows in the second table, okay, in the second table, then only, okay, and then only the row is returned. A row of T1 is returned only when the T1 dot X does not match with any value of T2. Okay. It means that we are going to reject the T1 if its value matches with the table 2. Okay, for example, okay, let's see. Patient is, for example, your T1 is patient and T2 is appointments. Okay, the condition is the patient dot PID is equal to the patient dot the appointment dot patient ID, indicating that we are looking for patients who do not have any appointments. Okay, so if there is an appointment, then this is rejected. If there is no appointment, the name is returned. Okay, for example, a student let's take an example of, okay, products. I don't want to confuse you with the students we discussed here. Okay, so for example, if we have a product stable T1 and then we have offer stable T2, then we want to find out the products who does not have any offer. So what do we do here? For example, we have offer stable. Okay, for example, 25% off. Okay, and then we have, for example, 50% off. Then we have, for example, summer off or winter off, or you know, any festival off. So, and then we have a product iPhone, for example. Now we want to check if iPhone doesn't have any of these offers, then we return the iPhone row. Otherwise, we don't. Okay, so this is about the anti-join, just the opposite of semi-join. Here, wherever there is a match, we return. We do not search for any other entries or any other, I know further search is not done. In the anti-search, as soon as a match is found, we don't return it. We want to look and return only those rows that do not match at all. Okay, with this condition. Okay. Now let's see algorithms for external sorting.